Hello, we're Paul and Gail, co-founders of Truck Sale. I thought it'd be interesting to talk about why we chose an enclosed design for the aerodynamic devices for large trucks and transport trailers. So, can you get into some of the details of the advantages of the enclosed design?
Okay.
Yeah.
So the benefits of this approach, this 3D design approach to boat tails, skirts, and gap fairings, is that it essentially allows for automatic function of these devices. And the benefit of automatic function is that, well, there's many benefits, but one of them is that you don't compromise on size, on full recovery of energy. Essentially, you can have the super truck performance in a practical sense. So we can put our automatic elements, that is the mechanism which allows retraction and deployment of the devices, inside an enclosure and thereby protecting it from the weather and ice and dirt and everything else that will essentially interfere with that function over time. So we have reliable automatic function, and then we have full size performance, which is full fuel recovery. It's there to be taken, and so we want to take every bit of fuel that's blowing in the wind, essentially, otherwise. Another key element to the enclosure is that we can put safety elements inside, like lighting, very effective safety lighting for the skirt in particular and the boat tail, and as well other sort of ADAS technology elements like radar, for example. We can put a radar element under the trailer in the skirt domain, low to the road at the level of cars and cyclists and pedestrians, with wide angle views, and have it not be fouled by ice and other, sort of dirt and things that will render it less reliable. Another big kind of theme, I would say, about the enclosed design is that an automotive body really should be a properly formed, smooth, geometric form. It shouldn't have edges that project into traffic for the boat tail, for example. We don't have any sharp edges that, at the level of vans or SUVs, many vehicles, the windshield and the cabin is well above the lower edge of a trailer, where a boat tail will occur if it's full-sized and fully working. So it's sort of, I think, the proper way to do it, like to have a good-looking, nicely geometric, fully formed automotive body. It looks better, it's safer, and it's just the complete treatment, in a proper sense. The boat tail in this form, too, by the way, has advantages to make the boat tail realistically workable. There's many nuances to the airflow in the boat tail effect that the 3D design kind of solves without, it just gets rid of all the trouble that otherwise would be present if you try to boat tail without a back surface. Basically, the bottom line of it all is it allows the boat tail to work at 100% what it should do, without any custom fitting or sealing of the boat tail to the trailer. So it can be applied universally to any box vehicle, any truck or trailer that's a rectangle. You could put our boat tail on very easily, install it rapidly, take it off rapidly, and have no concern about the particular geometries or hardware elements to that truck or trailer. So it's just kind of a very practical aspect, which is not obvious unless you realize the difficulties with a two-dimensional boat tail. That is panels only. Not only the sharp edges, but the sort of need to seal the perimeter otherwise, which is very impractical. And it has to be kind of then applied to each particular vehicle in a custom manner, which we don't have that problem. We just, you could tack it on to any box vehicle and it will work at 100% what it should do. There'll be no losses from lack of seal, lack of perimeter seal. It's a subtlety of boat tailing which is not really understood or known to most, who would know this. I kind of know this because I spent time with Kevin Cooper, who was like a guru of aerodynamics at the National Research Council in Ottawa, Canada. Mm-hmm. So he kind of taught me some things here that we have used forward here to make a boat tail that is like a universal, system for any box vehicle